functionalities of stacks and queues once again. Here, stack and queue. So basically stack follows last in first out property. That means the element that was inserted in the last will be deleted first from the stack. You can think stack as an array where you will insert and delete elements from only one end, and that end will be called as top of the stack. So basically we will create an array and we will insert the elements into the array with the top index of the stack. If we want to insert any element, then we will increase this top index and we will store the element. If we want to delete an element, then we have to delete the topmost element of the stack. So here the topmost element of the stack is 2. So if we are wishing to delete something, we have to delete 2. Okay. Here stack supports two functions that are your push x. That means if you will call this function push, then that data item will be pushed into this stack. And one function pop. Pop is used to delete the topmost element of the stack. So basically you will create an array, then you will keep on calling the push functions, and when you will wish to delete an element, then you will call the pop function. Fine. Suppose we want to insert 6 in the stack. What you will do, you will call push 6. So push 6 means you want to insert 6 on the top of the stack. So this top will pointing to this position and 6 will be inserted here. Okay, 6 will be inserted here. Now suppose if you want to delete this 6, so you will call simply pop. So pop will delete the topmost element of the stack. Here the topmost element is 6, so 6 will get deleted from the stack and the top pointer will now pointing to this. If we will call pop operation one more time, then this 2 will be deleted and your top variable will be pointing to this data item. So stack follows last in first out property with operations push and pop. Here queue supports first in first out property. That means the element that was inserted first will be deleted first. Fine. So here also you can take an array and here you need two ends of the array for insertion and deletion. Here we have to insert or delete from only one end, and that end was your top variable. Okay, here you will delete from one end and you will insert from other end. Okay, so the end from where you will insert, you will call that end as rear end. Okay, let's insert something in this queue. The queue is containing these many elements and we will insert the elements at index rear and your front will be somewhere here. If you want to delete 8, then this front will be incremented and the 8 will be deleted from this queue. So here it supports two operations. One is your insert x, that will insert the element at the rear end. Other is your delete operation, that will delete the element from the front index. Fine. So these are the basic properties that you must be knowing on stack and queues. Now we will look on the problems. So the first problem is we have to implement a queue with two stacks. You know the property of queue. So the queue works on the property of first in first out and stack works on the property of last in first out. Now we have to implement a queue with two stacks. Here we have taken two stacks. One is your S1 and other is your S2. Okay, and we have made some rules so that we can implement the queue. Okay, so whenever you want to insert any item in the queue, you will call simply push operation on stack 1. So whatever you want to push, whatever you want to insert in the queue will be pushed into first stack. Suppose we want to insert elements 5, 8, 3 and 1 into the queue. We will call push s1 comma 5, push s1 comma 8, and we will push all the elements into first stack. And our top, I'm calling this as top 1. So top 1 will be pointing to the topmost element of stack 1. So it is very simple. Insert operation is very simple. You need to remember here that we are inserting all the elements in first stack. Now suppose you want to delete some items. So since we are implementing a queue, then because of property first in first out, the elements 5 should be deleted first, then 8 should be deleted, then 3 and then 1. So we will follow this procedure for that. If S2 is empty, yes, your S2 is empty. If S1 is empty, this will be your initial case because initially there was no element in stack 2 and there was no element in stack 1. So both stacks were empty. So that's why Q will also be empty. S2 is empty, fine, but S1 is not empty, so this will not execute. Now we will come to the else part. While S1 is not empty, S1 has some elements, then we will pop the element from S1 and we will push those into S2. So we will pop 1 and we will push 1 in S2. We will pop 3 and your top 1 will be decrementing. Here your top 1 will be pointing to 3 and you will pop this 3 and you will push this in S2. Now your top will be 8. Now you will again pop 8 and you will push it in S2. Then you will delete 5 and you will push this in S2. The top 2 of this stack S2 will be now pointing to the element 5 and this top 1 will have no element now. All the elements of this stack have been popped, so this is now empty, so this condition will be false. Now you will pop from S2. You are getting 5 here. That is what we were wishing. Okay, so we will make some rules here. Whenever we want to insert something in the queue, we will push that element into first stack, and whenever we will wish to delete an element, we will check two things. The first thing is if there are some elements in S2, then we will not do anything, we will simply delete the element, because if there are some element in S2, then it is saying S2 is empty. Since there are some elements in S2, so S2 is not empty, that means simply the pop operation from S2 will take place. Okay, so the elements from S2 will be deleted. But if the second one is if the stack 2 is empty, then all the elements from stack 1 will be popped one by one and then will be pushed into stack 2 in one by one, and then we will delete the element from S2. Fine. So with this way we can implement queue with two stacks. This question was asked in K 2006. Okay, so with this you can implement a queue with two stacks. Now in this problem we have to again implement a queue with stack, but here we have to use only one stack. Also we are given a function that is reverse, okay, that will reverse the elements order in the stack. Now suppose we have a stack, okay, so what should be your insert operation? So simply for insert operation you will simply push the elements into the stack, no problem. Okay, so we can push, okay, so this will be your top and this end we will use as your rear end of the queue. Okay, now for delete operation, what should be deleted in this case? Element 8 should be deleted because of first in first out property of queue. So now we have to do something as reversing the order of all the elements. So we will call a function reverse, since it is given in the question that stack can support a reverse function. Okay, so we will call reverse function. It will reverse the order of the elements. So it will become 8, 3, 2 and 5. Now we will perform pop, because now 8 is your topmost element and we can delete this by calling pop function. Fine, so 8 will be deleted. Now your if you want to delete a element just after 8, you can delete, you can call pop function again. But if you want to insert something else, so you have to leave this stack into initial state. Okay, so you will call reverse function again and it will reverse the order of the elements again. Now you can see this is the correct order of the elements that should be in stack. So what you will do for insertion, you will simply call push function. For deletion, you need to call one reverse, then pop, then one reverse. That means two reverse of functions and one pop function. Fine. You can also follow another approach where your insertion will be costly. That means here you can see here insert will take only one operation but deletion will take three operation. But you can also implement this as where deletion will take only one operation and insertion will take the three operations. So with this approach we can implement a queue with only one stack and reverse function.